Today we're going to take a look at a rate law problem where the first step in the mechanism is not the slow step. So we have to approach this problem a little bit differently than others, in that the overall reaction is much more important. So let's write out our overall reaction here. We have H2 plus Cl2 to yield 2HCl. Looking at our mechanisms, we know that the slow step generally dictates the rate law. However, in this case, you can notice something a little bit off. Here, you'll see that Cl2 isn't actually in the slow step. For any of the problems where you're given the slow step as not the first step, it's always a really good idea to double check to see if the reactants are found in the overall reaction. So what we have to do now is write out this Cl in the equivalent of Cl2, which is why we have this first fast step. So to do that, we'll write out our rate law from our slow step. We know that the rate law should be Cl H2, each to the power of 1. Now, we know that Cl2 isn't in the rate law here. So that means that we have to use this first step and see how we can make the equivalent of Cl2 from Cl. So let's simply write Cl2 in terms of Cl. So we know that Cl2 is equal to 2 Cl molecules. And we know that we have only 1 here, which means that 1/2 Cl2 is equal to Cl. So we know because this is a rate law, we have to raise the stoichiometric coefficient to the power of the concentration. In doing so, we can replace the Cl here with Cl2, and we simply raise it to the power of 1/2. So the overall rate law then should come to equal rate equals K concentration of Cl2 to the power of 1/2 times the concentration of H2. And that is how you do a rate law for a problem where the first step is not the slow step.